A warm welcome to all. Um, the last and final type of failure in the lecture series is this creep. Okay. The creep failure is a type of material failure that occurs under prolonged exposure to high temperatures and constant or slowly increasing loads. So unlike the fatigue failure, which occurs due to cyclic loading, this creep failure occurs as a result of gradual deformation in the material over time and when subject to a constant loading at elevated temperature. The key characteristics of this creep failure includes time dependent deformation. The creep is characteristic by a progressive deformation of a material under a constant load at elevated temperature. This deformation occurs slowly over time and may continue for extended period before failure. The second one is temperature sensitivity. Creep deformations increases significantly with temperature, and the higher temperature generally results in faster creep rate and shorter time to failure. This creep behavior is often described using creep curves, which illustrates the relationship between the strain and the time at various temperatures and stress levels, which we will discuss it later. The third one is stages of creep. Creep deformations typically progress into three distinct: primary, secondary, and tertiary. During primary creep, deformation decreases over time and as strains accumulates. Secondary creep is characterized by a relatively constant deformation rate, while tertiary creep involves an acceleration of deformation, leading to eventual failure. The fourth one is the microstructural change. The creep deformation involves the movement of dislocation within the material crystal structures, leading to microstructural change such as grain boundary sliding, void formation, and grain growth. These microstructural changes can contribute to the propagation of cracks and eventual failure. The fifth one is fracture mechanism. Creep failures can occur through various fracture mechanisms, includes grain boundary sliding, intragranular cracking, transgranular cracking, and decapitation. The specific mechanisms depend on the factors such as material composition, temperature, and stress level. This creep failure is a concern in application involving high temperature environments such as power generations, aerospace propulsions, and structural components in the industrial process. And the design strategies to mitigate creep failure includes selecting materials with high temperature creep resistance, minimizing stress concentrations, controlling operating temperature, and implementing specific periodic inspections and maintenance programs to detect the sign of creep deformation before catastrophic failures occurs. Additionally, advanced materials and coating designed specifically for high temperature applications can help to enhance the resistance to creep deformation and extend component lifetime. As I said earlier, now we are going to see about creep curve. This creep curve is a graphical representation that illustrates the relationship between the strain of a material and the time it is subjected to a constant load at elevated temperature. Creep curves are commonly used to analyze and understand the creep behavior of a material, particularly metals and alloys, under high temperature conditions. The typical creep curve has three distinct stages. First one is primary creep. During the primary creep stage, the material initially experiences rapid deformation, but the rate of deformation gradually decreases over time. This stage is characterized by a decreased slope on the creep curve. This primary creep is often associated with the accommodation of initial dislocations and distribution of stress within the material. Secondary creep. This secondary creep stage follows primary creep as characteristic by the relative constant rate of deformation over time. In this stage, the slope of the creep curve becomes nearly constant, indicating steady state creep behavior. The secondary creep is governed by a balancing between dislocation moment and annihilation within the material crystal lattice. The last is tertiary creep. Tertiary creep occurs after an extended period of time and characterized by the acceleration of deformation leading to eventual failure. In this stage, the slope of the curve increases rapidly, initiating rapid strain accumulation and the onset of local deformation mechanisms such as necking, void formation and crack propagation. Tertiary creep often accumulates in material failure due to the propagation of cracks or attainment of critical strain level. So that's all for today. Thank you and have a great day.